name is Emmanuel Chauya. I'm a biomedical engineer from the Oxygen Alliance, and I'm speaking to you live from Lilongwe, Malawi. The Oxygen Alliance brings you Oxygen Talks and Partner Talks that are tailor-made to equip biomedical engineers and any other professional in the health sector with knowledge on equipment that uses oxygen.
Like I said, my name is Emmanuel Chauya and I'm hosting the call from Lilongwe, and I would like to know where you are joining us from. So just type your location in the chat, and also you can share with us your email so that we can add you to our emailing list, and when we have calls like this, we send you invites and constant reminders. Presenting to us today is one Eddie Guy, who is a service engineer for Aeonmed, and he'll be presenting on the subject understanding anesthesia technology, especially on the 7200A model of Aeonmed. So without wasting much of our time, let me hand over to Eddie Guy for the presentation. Over to you, Eddie.
Thank you, Emmanuel, and hello everyone. I'm Eddie from Aeonmed, and today I will introduce our product, Anesthesia machine, 7200A. And firstly, I will introduce my company. Beijing Aeonmed was established in 2001, a manufacturer of OR and ICU machines. We can provide with you anesthesia machines, ventilators, operation lights, operation table, and so on. We have developed business over 160 countries. And we have 5 R&D centers and 3 manufacturer bases and 8 overseas subsidiaries, and have more than 50 overseas office. And I know before this you have learned about the Gloster event and universal anesthesia machine. You must have a basic knowledge of anesthesia machine. Okay, let's get the topic of today's presentation. Today's presentation will be include 8 main parts: product description, components, operation theory, user interface, and pre-operation preparation and operating guide, cleaning and disinfecting, and user maintenance. This is the general information of anesthesia machine. Anesthesia machine is a continuous flow anesthesia system which offers manual and automatic ventilation, easily adjustable fresh gas delivery. This machine mainly to keep the patient unconscious and support their breath. And there are some warnings and cautions. Anesthesia machine is not suitable for use in a magnetic resonance imaging environment. And our machine, 7200A, the highest altitude is 4,600 meters. The pipeline inlet pressure must be 280 to 600 kilopascal. And the anesthesia system must conform with this standard. For example, the pressure measurement must meet the ISO 80601-213. And let us have a look of the front view of 7200A. You can see number 1, the flow meter. And number 3 is the flow rotary knob. And we have a pole which can prevent the misoperating. Number 4 is the pressure gauge of the gas source. And we have the touch screen, 10 inches. And number 9 is the vaporizer. We have 2 positions for vaporizer. And we can provide the vaporizer of isoflurane, sevoflurane, enflurane, and halocene. We have the table for working. And number 2 and number 5 is the breathing system. Number 2 is the bellows. Number 5 has some valves, one-way valves, and the breathing port, APL valve, and the carbon dioxide absorber. And number 6 is the ACGO, which usually used with the open breathing circuit, such as main circuit and Jackson-Race circuit. Number 7 is the oxygen flush button, which usually used to output the high flow oxygen and flush the breathing system with oxygen and help patient to get wake up after the surgery. Number 10, we have 2 drawers which can store some files of doctors or some accessories which can use in the surgery. Number 11 is the catheter with the brake. Let's see the details of our flow meter. Our flow meter is 2 tube types. And for 7200A, we have 2 configurations. The basic configuration and the full configuration. In the basic configuration, we supply 2 gas, oxygen and nitrous oxide. And for the full configuration, we supply 3 gas, oxygen, nitrous oxide, and air. Each gas has 2 tubes. And one of them, the range is from 0 to 1 liter per minute. The other is from 1 to 10 liter per minute. This design is usually used in the mini flow anesthesia because the first tube is more accurate for the flow. Okay. Next part is the pressure gauge for the gas source. We have 2 rows of the pressure gauge. The first one is for the wall gas, and the second one is for the cylinder. You can see for the central gas, there are green area which can indicate for the doctors the normal working range. If the gas pressure is in the green area, the machine will work normally. Okay, next part is the vaporizer manifold. And for 7200A, we have 2 positions for the vaporizers. And we use the SelectTech standard, which means we only make sure the vaporizer using the SelectTech standard, it can work with our machine. Okay, next part, let's have a see of the back view of 7200A. Number 1, power switch. Number 2 is RS-232 interface. This interface usually used with the carbon dioxide and the agent module. Number 3 is the fuse, which can prevent the voltage getting too high and destroy the machine and make it danger. The fuse will burn out to cut off the power. Number 4 is the auxiliary socket. In surgery room, doctors usually use other electric devices, and if they need the power, they can use the auxiliary socket of our anesthesia working station. Number 4 is the power cable. Number 6 is the yoke. This yoke is used to install the cylinder for oxygen or nitrous oxide. Number 7 is the battery. If the battery used for a long time and it's not working anymore, we can let technicians to open this cover to replace the batteries. Number 8 is the speaker. Our anesthesia machine has the visual and the studio alarm. So if the machine giving alarm, the speaker will give doctors a sound to remind them. Number 9 is the gas inlet. Number 10 is the driving gas interface, which need to connect a tube with the bellows to provide the driving gas into the bellow cover. The driving gas is used to push the bellows down and input the fresh gas to patient. Number 11 is the exhaust port. Next part is the breathing system. The breathing system divided to two main parts. First part is the bellows, bellow cover, bellow base. The second part is the breathing system, which includes the airway pressure gauge. A doctor can check the airway pressure through this gauge in manual mode or other mode without electricity. Yeah. Number 3 is the APL valve. The APL valve name is adjustable pressure limit valve. This valve is used in the manual mode. You can set a value and the pressure of patient won't get higher than this limit. This is a valve designed for safety. Number 4 and number 6 are the breathing valve, which makes sure the gas flow in one direction. Number 7 and number 9 is the breathing port. 7 is the inspiration port, and the number 9 is the expiration port. Number 8 is the port to install the manual bag. If doctor need use the manual mode, they need connect the manual bag at this place. Number 5 is the carbon dioxide absorber, which need some soda lime to absorb the carbon dioxide the patient exhaled. Okay. Next part is the bellows port. This is below the bellow base. There need to connect some tubes. One tube is driving gas, which connects to the back of machine. Number 3 is the tube connects to the breathing system. Number 2 is the exhaust gas part. Okay, next is our vaporizer. Our vaporizer have two types, VP300 and VP500. And as I introduced, we can provide 4 agent type: sevoflurane, isoflurane, enflurane, and halocene. And we have 3 filling methods. This one is the pour fill, which means you need add the agent by pouring. The other 2 is quick fill and key fill. And they need the adapters to fill the agent. And it meets the SelectTech standard. It has interlock function. The number 2, interlock bots. What is interlock function? That means because 7200A has 2 positions for vaporizers, and the doctors can't use 2 agents in one surgery. So if you open one of the vaporizers, the interlock will working and prevent the other vaporizers to open. Number 8 is the indicator for the agent. Okay. And if you want to drain out the agents of vaporizer, you can screw this valve, number 9, the drain valve, and the agent will get out from the drain hole. Next part is anesthesia gas scavenging system. This system is useful to deal with the waste gas of breathing system, and one of the ports needs to connect the scavenging port of hospital, and one of these ports need to connect the breathing system. You can set the flow and adjust the working power of the scavenging system. Next part is the pneumatic principle diagram. This diagram is for technicians to check the gas flow, where the gas come and where the gas go. If our machine have some leakage, you can check with this diagram to find out the leakage happen which place. And you can see for the 3 gas source, we have 3 regulators which produce the pressure. And we have the regulator for driving gas. And number 10 is the flow meter. Number 11 is vaporizer. 12 is the oxygen flush valve. And the breathing system, bellows, and switching valve, which can switch the automatic mode to manual mode with this valve. Next part is the pipeline gas inlet module. We have the gas source pressure electronic board to detect the pressure of gas source for oxygen. So if the oxygen pressure is not sufficient, the machine can give the alarm the oxygen failure or oxygen pressure low. And here, number 5 and number 7 is the flow valve and the gas module, which can control the tidal volume. Next part is the cylinder gas inlet. This is the yoke I introduced before as the back wheel of the machine. And inside the yoke, there are the regulators to reduce the pressure of cylinder to meet the standard of machine. Our yoke use the cylinder often use 4 liters and index. Next part is oxygen flush valve. The gas from the oxygen after the regulator and the output will go to the CGO, which is common gas outlet, and going into the bellows and going into patients to flush with oxygen. Okay. Next part is the electrical system. All in all, the electrical system is the main board getting the signal from sensors and giving the signal to control the valves and get power from battery or the AC power. We have the valve such as main switch and the valve of the gas module, and get the sampling from the sensor board. And the communication and display is for the screen display. Encoder is for the shuttle knob to adjust the value. Function key is connected to the communication board. The communication board is behind the screen. Let's have a look of our electronic boards. The power supply board giving power for main board and the solenoid valves. If the machine have the problem of power supply, we can check if the cables connect well. And I pointed this ports, such as J1 is connect to the battery, J2 connects to switching power connector, and P2 connects to power supply. This is usually for the main board and giving power for the main board. J4 is for communication. And this is our main board, main control board. Getting power from power supply, the J6, and control the expiratory valve, J2. J3 is control the switching, manual and automatic switching. J4 control the inspiratory valve. J12 is oxygen sensor module. Later, I will introduce how to install the oxygen sensor. J5 is for communication. And you can see there is the flow sensor, which installed on the main control board. This as the high, low, we use the difference of the difference of the pressure flow sensor and get sampling from the breathing system to get the flow. Next part is the communication board. The communication board is behind the display screen. If the display function display screen not working, we can check the cable. If the cable connects well of this board. G2 the knob connector. Knob is the shuttle knob. And the J1 key function key connector. JJ1 and the J4. The serial port connector is usually used to input the software. So our technicians in customer side usually doesn't need to use this port. Next one, let's have a look of the user interface. As I introduced, there is a shuttle knob, the manual auto switch key, and the mute key. If the alarm is not important and doctor want to mute, they can push this. Number 2 is the indicator for AC power. And the mute key will keep for 110 seconds. Okay, let's have a see of the details of display. On the left and top corner, there is a ventilation mode. Now we're using the IPP Remote. And the bottom bar is the adjusting area. We can adjust or set the parameter by tap this and rotate the shuttle knob. And in middle is three waveforms: pressure, time, and flow time, and volume time. And on the right side is the monitoring area. The alarm area is number 4. And we have the function key on the right, number 7. Okay, let's get the details. The setting parameters. Each ventilation mode have their independent parameters. You can check, such as IPPV, you can set the tidal volume, frequency, and inspire-expire ratio, T plus, and then PLV, pressure limit ventilation, synchronized intermediate mandatory ventilation, spontaneous ventilation, and manual mode. And the alarm is divided to 3 levels. The highest level is right background, and the sound will hurt very quick to alarm the doctors. Immediate alarm is yellow background, and the low level is blue-green background. And the X is the mute button. Okay. And we can display string waveforms. And if you select the carbon dioxide and agent module, you can monitor the carbon dioxide waveform as well. And we can display 2 loop pressure volume loop, and the flow volume loop. And for the function key, number 1, alarm setting. You can set the upper limit and the lower limit of alarm. System setting, you can enter to the system to changing some settings for the system. Calibration, which you can calibrate oxygen sensor, pressure sensor, or other thing you want to calibrate. Service is usually used in the case of the machine not working. Loop, you can turn up the loop by press this button and get back to main interface through the normal. And here is the connecting method of the tubes, which connects the tube from bellows to breathing system, connects the bellows to the machine. This is the driving gas, and connect the tubes or breathing circuit to patient. Next part is the oxygen sensor and how to install the oxygen sensor. We have an adapter to install oxygen sensor, like this, the T piece. And this end connect install the oxygen sensor and connect the cable to the back of machine. And then you can connect the breathing circuit for patients. Please, I want to remind that the oxygen sensor must be installed in the inspiratory port. Then you can get the accurate oxygen concentration. Next part is the mainstream carbon dioxide or agent module. Mainstream, you need an adapter to connect in the breathing circuit. And the other end connect the RS-232 interface at back of the machine. We use the Massimo gas module. And this is a side stream carbon dioxide and agent module. Of the side stream, there is a sampling line. And you need to connect this to the module. The other end is connecting the circuits. And the cable end connect to RS-232 interface as same as the mainstream. Next part is the AGSS connection, the scavenging system. As you see, you need to connect the tube from the system to the exhaust port at back of machine and back of the breathing system. You need to connect 2 second tubes. So as there is a Y piece, Y connector. Okay, next part is when you start the machine, we will enter to a self-test of system. And it includes automatic leak test and manual test. This test is usually used to test if the machine have leakage. Next part is the calibration. In the calibration interface, we can calibrate the oxygen sensor. And the oxygen sensor I introduced before is the chemical oxygen sensor. And it always have the expiry dates. And it needs calibration after replacing. and gas module calibration, leak test, complex test, and touch screen calibration. Service. The service function is usually for the technician. Password is 2010. You can calibrate more components of the machine, change the gas standard, change the language, and add the optional function, such as if you want to add the carbon dioxide module function after the machine shipped out from factory. You need get communication with us, and we will give you the code of machine to add the function. And check the software, test the voltage and load. Okay, next part is the details calibration for pressure sensor, flow sensor in hell valve, change the gas standard, and input new codes of the configuration, such as the carbon dioxide function. Check the valve, check the voltage of sensor valve and calibration. Get the voltage of sensor and check the software. If you need to update the software and you need to check this information. Next part is for the maintaining, such as cleaning and disinfecting. We have 4 methods of suggestion for the cleaning and disinfecting. Doctors can check this form for reference. A method is wiping, B method is washing, and C method is immersion, D method is autoclaving. The most parts of the machine is is showing here, such as you want to make a disinfecting of APL valve. You can check here. APL valve can use all 4 methods of cleaning and disinfecting. And for the vaporizer, we suggest only for A method. It's wiping. You can't autoclave or wash this part. Next part is user maintenance. And I mainly want to suggest this for the oxygen sensor and battery, because the oxygen sensor is chemical oxygen sensor. So it has the expired date. You need to pay attention to that if it is expired. Weekly to perform the 21% oxygen calibration, and monthly to perform 100% oxygen sensor calibration. And for the battery, I suggest the doctor or technician to charge and discharge the battery if the machine hasn't used for 3 months. So you need to pay attention to it for store condition. You need to pay attention to maintain the battery. And the other suggestion is for replace the components which are broken and replace the oxygen sensor 1 year generally. Okay. And that is all for my presentation. You can give your comments and question freely.
Thank you very much, Eddie, for the wonderful presentation. And indeed, as Eddie has highlighted, this is time for our audience to give in questions and comments on the presented topic. And there are two ways to this. You can ask in the chat or indeed raise your hand so that I mention your name, then you can ask your question. At this point in time, over to you, our audience. Thank you very much. The first one is Vincent Okello. So Vincent, you can go ahead and speak to us.
Hello, can you hear me?
Yeah,
Very loud and clear.
very well.
Okay. Yes, I'm Vincent Okello. Yes,
Nice to meet you.
I'm a medical technician. So my question was about the 100% oxygen sensor calibration. For the Aeonmed
Yes.
7200A, it doesn't have that option. It only has for 21% calibration. Or is there a way forward we do it?
The 100% calibration is in the service mode.
Yeah.
Did you check it?
No, it doesn't have the 100% because when calibrating the oxygen sensor, I guess we usually start with the 21% calibration, and then after that one passes, you proceed to 100% calibration. But now, the Aeonmed 7200A that we have doesn't have the option for 100% oxygen sensor calibration.
他看到这个胶卷是在外面那个胶卷，然后100的胶卷在Solos界面里面需要密码的。100的胶。
Yes, 7200A has the 100% calibration in the service page. I will show you in the presentation. Wait a minute.
Okay,
Eddie,
another question.
While you're looking that up, let me ask Vincent for one point of clarification. Vincent, do you own a 7200A?
Yeah, in our facility we have.
Okay, and you're saying from the one that you have, you are not able to see the 100% oxygen calibration. Is that correct?
Exactly.
Okay, so Eddie, is it possible that he has an old version of firmware or something like this?
Yes, perhaps because our 7200A has produced for more than 10 years, and we have different types for this model. So I believe the version of your machine perhaps is the old firmware, and we have the newest version of the machine in 2021. We can perform the 100% calibration.
Can I suggest that that Vincent follows up with you directly, and he can share his serial number and model number with you, and then you can get back to him to make sure that he has the correct information.
Yes, for this case, I can follow you, Vincent, to check that machine furtherly.
Okay, so and the last question, it's about when we are doing the test. That is the daily normal test. That is the leak test, the safety valve test, and the automatic leak test. Now, our machine, when you are performing safety test, if you start with the other test, that is the leak test, it will fail. If it will fail, but if you start with the safety valve test, the safety valve passes. Could it be there any problem?
You mean the safety valve test can pass and the leak test fail?
No, what I mean is this: when performing the test, we normally start with the leak test, the manual, then the automatic, and then the safety valve test.
Yes.
And now, if you follow that order, when you reach to safety valve test, it will fail. But when you start with the safety valve test, the safety valve test will pass.
So
Yes,
just to clarify, the sequence in which you do them is affecting whether it is passing or failing the test. Is that correct?
Yeah. So we don't know if it is our safety valve machine that has a problem in terms of safety valve test, or is the sequence that we do that is not correct.
I think that won't be the problem for the components.
Okay,
so
I think what can happen here is that, okay, for now, maybe Eddie, you can just give us the order of or the sequence of performing the test. And as Jerry has emphasized that the two of you have to get in touch, then I think the other problems that are being encountered by our colleague in Kenya can be handled that way. Would also be glad to be in the loop of the conversation. Thank you.
Okay, thank you.
Yeah.
Right, so we have other questions in the chat. And the first one is from Elizabeth Ntapalapa, who is saying, I would like to know what IPPV mode is and why you choose this mode. Also, what's the difference between the IPPV mode with the with the rest of the modes?
Yes, I got you. And IPPV mode is usually can be understood as the volume control mode, the same as the ventilators. It is controlled by the volume. You can set the tidal volume and other parameters. The main parameter is the volume. It controls by the tidal volume. Wait a minute.
Okay, so whilst Eddie is pulling up the presentation, Vincent, you can just share with us your email so we can connect you to our colleagues from Aeonmed.
You can check this difference, IPPV mode, and set the tidal volume, and it will control accurately. If you set 500 milliliters, and the machine will give 500 milliliters fresh gas to the patient, and the other modes, such as PLV, which mode the main parameter is the P-limited. You set this value, and the machine will control to achieve the tidal volume and under this pressure, under the P-limited pressure. And SIMV mode is for the patient who have their spontaneous breath, and there will be a parameter of the trigger. The machine will get the trigger from the patient and give the support of the gas. Spontaneous ventilation mode is all detected breath. The machine gets the trigger from patient and gives support. This spontaneous ventilation mode is usually used in the patient who is conscious after the surgery and getting wake up in this situation. Is that clear, Elizabeth?
Yes, it is clear. Thank you.
Thank you very much. And we have another question in the chat. This is from One Chimwemwe TS, and he asks to say, in cases where there is no external oxygen source, does the unit, in this case the machine, have the option to use room air as a carrier gas?
Sorry, for our machine 7200A, the oxygen is necessary. You need to connect to the central gas or cylinder. And if you have no external oxygen source, the machine can work hardly.
All right, thank you very much for the feedback. And we have a hand from Gerard Douglas. You can go ahead and talk to us.
Thank you, Eddie. I have a question regarding the oxygen sensor. You mentioned that you are using the electrochemical sensor, which has to be replaced every 1 or 2 years. I know that many oxygen analyzers are using an ultrasonic technique, and I wondered what was your design choice to go with electrochemical compared with ultrasonic?
We have used the paramagnetic oxygen sensor on our other model, such as AG70 and 8800A. But for 7200A, the configuration is for chemical sensor, which is cheap for some users.
So you're saying it's a cost consideration that electrochemical is cheaper than ultrasonic?
Yes, and I believe the concentration testing the chemical sensor will working well. And just make sure it's in the not beyond the expire dates.
So the ultrasonic sensor, I think, is also very accurate, and it can last for many, many years, 10 years or more, without replacement. So if we consider the cost and we look at total cost of ownership, in 10 years, you may pay for 5 electrochemical sensors, but in 10 years, you may never have to replace the ultrasonic one. So I think the cost argument, I'm not convinced on that one, but on accuracy, I do not know.
Okay, sorry for this question, and I need to get in touch with our research and development departments, and they designed the machine for this configuration, and they didn't choose the ultrasonic oxygen sensor.
That's fine. We'll wait for your feedback on that one.
All right,
Okay.
Thank you very much. And is there anyone else? Our time is running out. We have 6 minutes before we wind up for today, but we would give a chance to 1 or 2 people to still ask questions or give in their comments. Is there anyone else who would like to speak? Well, silence means that there's no one who would want to ask questions. That would also mean that the presentation was clear. And once again, thank you to our partners, Aeonmed and Eddie Guy, for specifically taking up the challenge and presenting to us. It's been an educative session. To our audience who have been with us all through up to this time, we would also like to thank you.